If you recall, we have studied about the bonds. We have studied about the sigma bond, and we have studied about the pi bond. We have solved some questions even, and at last I gave you one question to solve, and then we have ended the period. Do you remember the question, dear student? Do you remember what question did I ask you to solve? Okay. See, if you look into the benzene C6H6, we can have our benzene in this manner. Three triple bond, and then each carbon is bonded with hydrogen. Can you tell me the hybridization for each carbon in benzene? If I say all the carbons, see 1, 2, 3, 4, 5, 6. Tell me the hybridization in the all the carbons of benzene. Come on, everybody. What is the hybridization in all the carbons of benzene?
sp2.
Which carbon? You are right, you are not wrong. You are absolutely correct. But which carbon are you talking
First.
about?
First.
Okay, then what's about second? First is sp2, okay. Then second?
All sp2.
Ah, you are right now. All this carbon in benzene, they have sp2 hybridization. Now tell me about this. We have three carbon, 1, 2 and 3. Tell me the hybridization for C1, C2 and C3. Come on everybody, make it fast.
sp2, sp1,
No, speak like C1.
sp2.
Okay, who is answering this question? May I know the name? Okay, no problem. Keep it up. What's about second?
sp3.
Second is sp3.
Yes, sir.
This is second. Huh, make it fast.
sp2, sir.
sp2.
Very good. What's about third? Good. What about third one? This one.
sp.
sp.
Correct. Absolutely correct. So now, my dear students, you have been understanding it. What's about the next one? You will tell me. See, we have CH3 NO2. What is the hybridization of this carbon?
sp.
Yeah, you are correct. Can you be a little louder?
sp.
How sp, beta? See, this is the structure. How could you say it is sp? This carbon. What is the hybridization for this carbon?
sp3.
Be a little louder, please. Vaidehi, you are right. Anyone else?
sp3.
Very good. Then this is the last question from my side. Tell me the hybridization for each carbon. This is C1, this is C2, this is C3. Everybody. You yourself even can draw this structure and understand the hybridization now. Now is it easy for you to give the answer? Tell me about the hybridization of this and this carbon. See, these are the sigma bonds, these are the pi bonds. This is even sigma, this is sigma, this is sigma, this is sigma. Tell me, make it fast. What if you are wrong? I'm not going to kill you. Come on, make it fast. Give the answer. C1, tell me the hybridization.
sp2.
sp2.
Very good. C2.
SP.
Why? Very good. Why do you feel fear? Yeah, it's absolutely correct. SP. And third,
SP2.
sp2.
very good. So now you know how to identify the hybridization, right? You need, like I need not to worry about. See, I would be happy if all of you have participated and given answer, but it's okay. Like, it's not that. Okay, dear student, then let us understand something more about hybridization. You know, we have three type of hybridization: sp3, sp2, and sp. You have seen that when we have sp3 hybridization, my dear student, in that case, the shape, if you look into, then the shape for sp3, do you remember what is the shape for sp3? For sp3 hybridization, we will have tetrahedral shape. If we have sp2 hybridization, then the shape is going to be triangular planar. And if you look into the sp hybridization, then the shape of the molecule will be linear. So this is the thing even you need to understand. Then if we think about the distance from nucleus. So if we have sp3 hybridized orbital, if we have, for that first we need to know the s character first. So if you look into the s character, see here we have four orbitals, 1s and 3p, thus total four orbitals. So the s character is 25%. Here we have 1s and 2p, and thus total we have three orbitals, and therefore s character is 33.33%. But here we have one s and one p orbital, and that is why the s character is 50%. Now there is something that we can understand, that more is the s character, more is the s character, less is the distance from nucleus. This is even interesting to know how is it so, why there is a less or why less is the distance from the nucleus. Let me explain you. See, your if you have a nucleus here, then you can easily understand that if we have s orbital, it goes around the nucleus in this manner. But if we have p orbital will be in this manner. This is how our p orbital is around the nucleus. Now think this s and p orbital combining, then if s and p combine and if s character is 25%, the new orbital will have, little more spherical shape in this manner. So this is what it is, sp3 hybridized orbital. If you have sp2 hybridized orbital, then it will have shape like this. So it goes, this dumbbell shape goes more spherical. But if you have sp, you will realize that you will have almost more, or even you can think of, almost like two spheres. So it is like this. This is how you understand the sp orbital. So this is your sp2, this is your sp3, this is sp. So more is the sp character. You can see that less will be the distance from the nucleus. So this is how, when the s character increases, the distance from the nucleus decreases. And thus we can say, my dear students, that the distance from nucleus distance from nucleus, if we think, we would realize that if we think of the distance from nucleus, so if we write the order, if you write the order for the distance from nucleus, we realize actually when we write the order for the distance from the nucleus, we realize that sp is more near to sp2 and sp2 has got the mediocre distance. sp3 is the farthest and sp is the nearest. So this is how, my dear student, we study about the distance from the nucleus. Now, my dear students, when it comes to the distance from the nucleus, we realize that more is the distance from the nucleus, more is the distance from the nucleus, less would be attraction for the electron filled in the hybrid orbital. So whenever, my dear students, the distance from the nucleus is more, nucleus will less attract the electron filled into the orbital. So when we think of the molecules which are made by going for some particular kind of hybridization, if we think of sp3, then we have methane, CH4. If we think of sp2, then we have the CH2 double bond CH2. And if we think of sp, my dear students, then we have CH triple bond CH. So here we have sp3, sp2 and sp hybrid orbitals. These orbitals which are making these molecules, these orbitals, if we look into the electronegativity, we would realize that the electronegativity order, we can write it as sp would be the most electronegative, sp orbital would be the most electronegative, sp2 would be mediocre in the electronegativity, and sp3 would be the least electronegative orbital in this particular case. Then, my dear students, we need to study the acidic character. Acidic character. That is what we should study. Now, if you look into this CH triple bond CH, which is your ethyne, you know that here in ethyne we have sp hybridization, and that is why this nucleus of your sp hybrid orbital will attract this electron present here in a strong manner. So we can say here we have a strong attraction, for the electron. So here we have a strong attraction for this electron by this carbon present over here. So whenever there is a bond between this carbon and hydrogen by sharing of electron, what do we realize? That this carbon attracts this electron in a great manner. This attraction for this electron is quite high or higher level attraction. So as these electrons, both these electrons for these bonds are attracted more by carbon, H plus can be easily released. H plus can be easily released, my dear students. Please remember that due to the attraction for the electron, this H plus can be easily released by ethyne. So suppose if you take ethyne, CH triple bond CH, and allow it to the sodium metal, allow it to react with the sodium metal, you will get sodium ethionide, Na plus, this H plus get released, and you get this compound sodium ethionide. Sodium ethionide. Now see what happens. This actually in turns gives us C minus triple bond CH plus H plus. Suppose if we take both two molecule of each of them, then we can see that we will get hydrogen gas released. So here you can see that this particular compound behaves as an acid. So this is your actually, this is metal that reacts with acid and that gives hydrogen gas and salt. As this is only one sodium is added, we will call it monosodium ethynide. We will add the word monosodium ethynide. If this monosodium ethynide, that is your Na plus C minus triple bond CH is allowed to react with further more sodium, you will get disodium ethynide, that is Na, then you have C, triple bond C and Na. This is what it happens, and again you will get the hydrogen gas released. So this is how you understand that our ethyne behaves as an acid. So ethyne has got acidic character. Do you understand, dear students, this? Do you have any doubt into this? बच्चों, क्या ये आपके समझ में आ गया है? इसमें कुछ पूछना है तो आप पूछ सकते हैं. Hello, dear students, do you have any doubt into this?
No, sir.
Okay.
No, sir.
Then let's move forward. So now if you allow, my dear students, if you allow sodium to react with C2H2, please remember C2H2 is your ethyne, you can get disodium ethynide, Na2C2 plus H2 gas. This is your disodium ethynide, Na, C triple bond C, Na. This is disodium ethynide. But now if you think about CH2 double bond CH2, or if you think about CH4, how do they behave? That is what we should know. Suppose to understand this, let us take one example. So what should be that example? Let us look into this. Suppose we have CH3, C triple bond C, CH3. Or if we have CH3, C, double bond, sorry, CH3, C double bond, CH2. Or if we have only CH4, or we can take CH3, CH2, CH2, CH3. Can you name this compound, any one of you? बच्चों, आप में से किसी को इन compounds के नाम आते हैं? किसी को भी? If you can try it out, you have studied in 10th standard. Anyone, please? Okay, no problem. Okay. Let us do it this way, my dear student, that if you take here triple bond and remove one H, and then if you take simple CH2 double bond CH2, if we have CH triple bond CH. Now if you allow it to react with the sodium metal, then it will give disodium product. It will give only monosodium product. That means it will give us CH3, C triple bond CNA, and there will be no reaction. Please remember, my dear students, that here we will get disodium product. Here we will get monosodium product, means the side where we have CH3, that side we will not be able to add our sodium, and here as both the sides CH3 is present, we will not be able to add Na. So what we simply understand here, my dear student, that this hydrogen which is bonded to sp hybridized carbon, the hydrogen which is bonded to sp hybridized carbon is the most acidic in nature. So if we compare the acidic character of this compound, order of acidic character, we can say that CH triple bond CH is more acidic than CH3C triple bond CH, and CH3C triple bond CH is more acidic than CH3C triple bond C CH3. Now, according to whatever we have understood, my dear students, according to the electronegativity, according to electronegativity, we even realize that CH triple bond CH is more acidic than CH2 double bond CH2, which is more acidic than CH3 CH3. This is what it is, the order for acidity, order of acidic character. So my dear student, this hydrogen is the most acidic hydrogen. This hydrogen is the least acidic hydrogen. And these hydrogens are mediocre in acidity or acidic character because they are bonded to a different kind of carbon. They are bonded to sp carbon, so they are most acidic. Here the hydrogens are bonded to sp2 hybridized carbon, and here the hydrogen is bonded to sp3 hybridized carbon. So the hydrogen which is bonded to sp hybridized carbon is the most acidic carbon among all these three. This is what I really wanted to tell you. Do you understand, dear students? If you have understood, please let me know. And if you do not
Yes.
understand, please ask your doubts. Understood? Okay. Then let's move and understand something else. Now, my dear students, we want to study about the pi bond. So let us understand what is the speciality into the. Let us understand what is the speciality into the pi bond. So do you remember, you must have know or you are well aware that pi bond is formed by the lateral overlap. Do you understand what is lateral overlap, dear students? Okay, let me explain you about the pi bond. That pi bond is possible by the orbitals which do not take part in the hybridization. First thing is this, that the orbitals which are involved into the pi bond, they do not take part into the hybridization. This type of orbitals, my dear students, these type of orbitals are generally available above and under the plane of the sigma bond. Here we will get the sigma bond formed. So these are the sigma bonds. But if you want to make the pi bond, you will have to have the orbitals available above and under the plane. This is how it happens. So here there is an overlap of the orbital. This is what it is known as the overlap of the orbital. The necessary condition for this overlap that it should be the lateral overlap. When sigma bond is formed, my dear students, we will have axial overlap. When sigma bond is formed, my dear students, we will have an axial overlap. This axial overlap is more than the lateral overlap. Please remember that axial overlap is greater than the lateral overlap. So this is what we can easily understand, that the axial overlap is greater than the lateral overlap. As this axial overlap is greater than the lateral overlap, we can easily understand that sigma bond is strong. Sigma bond is strong and compared to the pi bond. So we can easily say that the strength of pi bond is less than the strength of sigma bond. Now, why do we get the lateral overlap? That is also the reason that why pi bond is formed by lateral overlap. What is the reason? The reason is the orbitals involved are the orbitals. The orbital involves are the orbitals that do not take part in hybridization.